Thank you, Auntie. Like Auntie mentioned, my name is Samuel Tillinghast, and I'm here today to talk about how painful it is moving from Selenium Library to Browser Library. This is a talk about my company's move from one of the main browser testing libraries, Selenium Library, to Browser Library. And first, I'd like to give you a little bit of background about me and about my company. I work at a company called Buffalo Computer Graphics, and they build a web-based system for emergency management. It's a ticketing system, and we have an office in Buffalo, New York, which is in western New York, and it's near Niagara Falls. So a little bit of background. We've been using Selenium Library since 2019, as well as Robot Framework. And we have noticed that in some ways, Selenium Library wasn't serving us particularly well. And we had heard talk about Browser Library and some speed improvements and native headless operation that we really thought would serve us better. We run a lot of our test suites from scheduled jobs that run from headless operation. And when we ran them from Selenium, we'd notice that we'd have some flaky or iffy runs of tests where they'd sometimes fail opening the browser. And our existing project structure made trying Browser Library a little bit easier. This project structure consists of 5 main layers. We have the lowest layer, which is our interface layer, which is where Python libraries such as Selenium and Browser Library and Robot Framework lie. We have libraries that we created ourselves via resource files, which is our support and libraries layer at layer 4. We have our layer 3, which is our user interface layer. This is the critical layer for us because it allowed a more abstracted implementation of Selenium Library and therefore made changing the backend a lot easier. Then we have our navigation layer, which is how we actually get to the pages that we'd like to test, either by navigating directly to them or clicking through the UI of our website. And then we have the testing languages itself, which is typically how our tests are written out. They mimic how a test plan would be written out for any particular page on our website. Like I mentioned before, our user interface layer is really the critical layer here. In our project, this is how it would appear. We'd have a UI utilities resource, which contains abstracted keywords such as click, getting an object's text, or entering text into that object. And these make calls of Selenium Library keywords. For example, the most simple implementation of these keywords is simply calling Selenium's click element keyword and having a keyword built on top of that. Now, let's say that we notice that in a lot of places, our keywords are getting, or our clicks are getting caught up on obscuring elements that are getting in the way of what we'd actually like to click. And we know that they'll disappear after a while, such as the loading panel. Well, we can introduce a keyword such as something called wait until element is unobscured. And we hand that locator over to that keyword, and then the keyword just waits until that element is available to be clicked. And in order to not have to write in this keyword in front of every single time that we call click element, we simply replace it in one place, and it fixes this issue every time we call click. Now, when we made the choice to move or to try out Browser Library, we introduced a couple new resource files. We essentially took our old UI utilities resource and moved it to this Selenium Library UI resource, and then created a mirror of it that included Browser Library implementations of the same keywords. And then UI utilities now includes a number of keywords that switch depending on which browser control you'd actually like to use. So we can actively compare how one browser control works to another. And we do this using a variable on the command line called browser control. If it's set to Playwright, which is the backend of browser library, we run our browser library implementation. If it's anything else, we run our old Selenium library implementation. Now, what was really easy for us in this process? The locators in browser library are quite straightforward when compared to Selenium library locators. The browser library, the main browser library locator strategies are actually a subset of the Selenium library's locator strategies, mainly being CSS, XPath, and IDs. The only difference between the two is that one uses a colon where the other uses a equal sign. So we simply have to do a text replace in order to get the locators to work in either implementation. And this, as I mentioned, the UI layer that we have in our project saved us a lot of time on implementation because we didn't have to go out and replace these keywords every time they appeared in our test. And that's something I'd recommend if you're starting a new web testing environment. I would highly recommend considering using a abstracted layer. So in case you want to try out a new backend, it's a lot easier to implement that backend. And despite the different iframe strategies that browser library and Selenium library used, it was actually quite straightforward to get them to a compatible state. And browser library already has keywords that do everything Selenium library keywords can do and more. So, as I mentioned, iframes. Let's say we're on some random website and we notice that there is an iframe on that website that contains a Twitter embed. If we want to get the text of that header that's in that Twitter embed, in Selenium library, you would first select the frame that you're interested in interacting with, do whatever keywords you'd like to interact with inside of that iframe, because if you don't indicate you're trying to work with an iframe first, you will never be able to see those particular elements inside of that iframe. So you first have to select the frame, and then you can interact with it, and then when you're done interacting with that iframe, you then unselect the frame. In browser library, frame selection is quite different, visually anyway. In order to get the text of that same header, you'd first prefix the locator that you ultimately intend to interact with a frame selector followed by 3 arrows, and then point to the end locator you intend to interact with. In our solution, we took inspiration from the Selenium library implementation because that's what we knew. We knew that first, so in our solution, we mimic the Selenium library implementation. So we select a frame object, and then get that object's text, and then at the end, we unselect the frame, similar to how Selenium unselects a frame at the end. And then you can go on continuing your test operation. So in order to implement that same behavior in browser library, we used a keyword that's quite new to browser library called setSelectorPrefix that lets you prefix all locators with a certain prefix. So for example, if we are not in our implementation of browser library select frame object, we check to see if that selector prefix is empty. If it's empty, we use that iframe locator and add the 3 arrows that indicate the frame is being selected. And then if the prefix is already occupied, that means that we've already selected a frame and we'd like to select another frame. So we take the old prefix and prefix it on top of our new iframe that we were interested in selecting. And then when we call getObjectText, which uses browser libraries getText on the back end, when getText uses that selector, it will automatically prepend that iframe to the selector that you're interested in selecting. And then when you're done interacting with that iframe, you simply unselect all frames, which in the browser library implementation of this keyword simply sets that frame selector, or that set selector prefix to none, because you're no longer interested in interacting with the frame. Now, what was painful? What was a difficult implementation for us? Without an abstraction layer, I could see that the development time would have been longer and potentially can make this process of transitioning longer. Not that I would say it's not worth it, but it would add some development time. Complex iframes, I still have issues with them in browser library sometimes, where previously they worked in our Selenium library implementation. Extending browser library historically has required a knowledge of Node.js. And we needed to find third-party libraries to replace ones that we had used previously that were built with Selenium specifically on the back end. We used a library previously that did image comparisons that specifically could capture elements on the page and then compare them to old screenshots of that same element. And if we want to have that same behavior, it's not that finding those libraries is difficult. We still need to replace the code and have it be more complacent with with the implementations we intend to use. And our JavaScript execution, one-off JavaScript execution compatibility was a little bit of a challenge. As I mentioned before, extending browser control requires different skill sets. In Selenium Library, you really, really only need to know Python unless you intend to specifically use JavaScript somewhere. And this is something that our team specifically had great background on. If you're developing things in Robot Framework, there's a good chance that you have a good background in Python, at least to a certain extent. And on our team, that's especially true. And Selenium Library has always supported multiple extension files. In Browser Library, you could historically extend with Node.js. However, recently they've added support for extending Browser Library through Python. Ultimately, you still end up often having to use some Node.js on the back end, as I learned in the advanced browser library workshop that I went to this week. But I think what this really speaks to is that also the browser library is getting active development, which is great to see. Now our in-test Java execution. In Selenium Library, JavaScript execution is done with a keyword called execute JavaScript, and in Browser Library, it's done with evaluate JavaScript. These keywords are both used with the intention of running one-off JavaScript code, and their implementations differ quite a bit. In Selenium Library, the implementation is a little bit strange, and in my opinion. It's all of the arguments for execute JavaScript are contained in one unpacked list called code, which then has a special token called arguments in it. And after that arguments token, all of the JavaScript arguments that you intend to pass to your JavaScript that appears before the arguments token are accessible with a variable called arguments in your JavaScript code. And you can access those different locations in that, past that arguments token with X, and where that's the position of that argument. And our abstraction, again, because we use Selenium Library first, took inspiration from this style and actually mimics the style of execution quite closely. So here's an example of what that would look like in Selenium Library. If you wanted to run an alert, for example, your alert message appears after that arguments token, and then can be accessed using arguments indexed at 0. And then the return string that we have can be accessed using arguments 1. In test Java execution in browser library, it takes 4 different arguments. We're really only concerned with 3 here. The first 3, there is the JavaScript itself, which is contained under an unpacked list as well, called function. And it also takes a selector argument, which adds a really useful function for any JavaScript that you're running. If you're interested in interacting with an element in your JavaScript, the selector argument will, in evaluate JavaScript, it will find that element and add it as an argument to your one-off function, and then you can access it. For example, in this arrow form JavaScript that I have below, the element found with this selector can be accessed as that element variable, and then can be used inside the JavaScript that you're running. Now, in practice, this is how it would look. You have a selector, such as maybe that header or a generic header, and then we want to access that text, and then we return it later. Now, that alert message that we had before is contained inside of arg. Now, some of our JavaScript utilizes the multiple arguments that you could pass in that unpacked list previously. And fitting those into one argument that you can pass in arg was a little bit of a challenge for us, but we figured it out. We converted our old argument style to a JSON serializable list in our browser library implementation that we then can access in an indexable way, in the same way that a Selenium library JavaScript would access those JavaScript arguments in that arguments list that can be indexed. And we made a helper function that converts the script to the arrow form that browser library requires for evaluate JavaScript. And then we added support for Selenium library to take a selector as an argument, and then when you find that element, you can access it in your script, similar to how browser library accesses an element found with the script. We just prepended a finding element portion of JavaScript to the beginning of our one-off scripts, and we find that element, and then we can interact with it in our scripts, which is much simpler than having to include that in every single one of your scripts that you intend to access an element in. So here are some takeaways. What we got in the end was Playwright's context structure, which saved us a ton of startup time with our tests. When you start a new browser in browser library, instead of starting a whole new browser when you start a new test, you simply instantiate a new context. And on every single one of our tests, when we started up a test, we'd save around 10 to 15 seconds of start time, at least on our machines, which across large test suites can save tens upon tens of minutes of time. And opening browsers for us, especially in our scheduled tests, has been absolutely more reliable. Where we were noticing in our environments that we were failing in Selenium tests maybe 10 out of 100 times, we've noticed it maybe once out of 100, which is a huge, huge improvement. And we're not really sure if that has to do with the environment or something we have to explore more thoroughly. Now, across this whole process that I would say took around 5 months or so for me to implement this new backend, IFrames still give browser library trouble a lot of the time. And specifically with a rich text editor that we have on our website. As soon as you try to access that iframe that rich text editor is, the browser library just freezes up for some reason and times out consistently. Sometimes it will say it's timed out and then just enter a holding pattern where like it could just stay there for like 5 minutes, even though the timeout's on a minute long. But Playwright's management of browser version and WebDriver has also been a huge boon to us. I have an asterisk here because, of course, maybe a couple weeks before, maybe more than a couple weeks now, but a few weeks before this talk, Selenium Library finally implemented a automatically updating WebDriver as part of Selenium's main Python implementation, which means that we still get the benefit of Playwright managing the browser version, which is something that takes it out of our hands. It can be more consistent. But it's less of a plus than it was previously. But the active community for Browser Library is huge for us. Through this whole process, I've been communicating with people on Robot Framework Slack, specifically in the browser channel, and they've always been willing to help and have been extremely helpful through this whole process of me trying to implement these things. So I have a brief demo of code running both in Browser Library and Selenium Library, and I run this code in Selenium Library first. It highlights elements on the page using a JavaScript script that we wrote that just highlights a random element, similar to how Selenium would highlight them. And we go to the Twitter page, highlight that element, and simply switching the command line argument variable browser control to Playwright. That same test, changing none of the code at all, runs in our browser library implementation. And I would like to say that this code will be available on my talk page on the RoboCon website. I think that having this code accessible will make the startup time, or the development time for anybody's desire to try this out a lot simpler. Because if you don't have to rewrite those keywords on both sides, it will definitely save people a lot of time. With that, I'd like to thank you all for listening to my talk, and I'll take any questions.